Hi, boys and girls. It's Miss Bissell. We are going to work on multiplication and division today. We're actually going to be learning something new in multiplication and reviewing what we've been doing in division. So I would like you to make sure you have a piece of graph paper out and a pencil. If you need to go get that, pause me, go grab your materials and come back because I'd like these two problems worked out with me. And then I would like for you to keep this in your binder behind math work so that if you need to review back to it, you can. So we're going to be multiplying by a two-digit multiplier. As you see, we have the factors 6,349 and 25. So this is new. We're moving into our 5th grade goal of being able to multiply by a two-digit multiplier. So the way that we start out is very much what we've been doing. We're just going to ignore the 2 in the tens place, and we're going to multiply by the 5. So we're going to multiply 6,349 by the 5. I'm going to use 2 colors of ink. I couldn't find my color pencils. I'm going to use 2 colors of ink to show you this. You just use your regular pencil right now. All right, so we're going to start just like we've been doing. We multiply each digit of the top factor by the 5 in the ones place, starting with the smallest place value slot and moving to the left. So 5 times 9 is 45. Okay, we regroup the 4. 5 times 4 is 20 plus 4, 24. Regrouping the 2. 5 times 3 is 15 plus 2 is 17. And 5 times 6 is 30 plus the 1. So we have 31,745. All right, now we have already used each of these numbers that we regrouped. So we're going to cross those out so we don't accidentally use them again. Now, this is the only thing that differs when you multiply by a two-digit number. We're going to multiply every digit in the top factor by the 2 tens. So we're going to multiply 2 times 9. Same process, smallest digit value to the largest. 2 times 4, 2 times 3, 2 times 6. But wait a minute, this 2 really has a value of 20. So every answer or product that goes on this line is going to be 10 times the value than just multiplying by the 2. So one very important step is that we put down a 0 here to represent that we're multiplying by 20, even though as we go through the process of multiplication, we're just using 2. I'll show you this in just a minute so it maybe makes some sense. So we're going to actually ignore the 5 now. I grabbed my different color, and now 2 times 9 is 18. So we put down the 8, regroup the 1. 2 times 4 is 8 plus the 1, 9. 2 times 3 is 6. We didn't regroup anything, so we just put down the 6. And 2 times 6 is 12. So I want you to think about something real quick. Let's just look at this partial product that we just wrote in blue. All right, so 6,349 multiplied by 10 would be 63,490, right? And if we doubled that, it would be 126,980. So what I'm getting at is 6,349 times 20 is going to be 126,980. If you think about 6,349 only being multiplied by 2, isn't your answer just going to be somewhere around between 12,000 and 13,000? And that's not what we have here. So number sense wise, we're really thinking about what this number would be times 2 and then annexing that 0 because we're really multiplying times 20. Okay, does that make a little bit of sense? Now, we're going to add these numbers together because what we have here are partial products. So the one right here in pink is really what happened when we multiplied 6,349 times 5. It's right here, 31,749 is that partial product of multiplying times 5. This number right here, 126,980, is what happens when we multiply 6,349 times 20. All right. Now, since they're partial products, we need to add them together to get our full product, which is the answer. So 5 plus 0 is 5. 4 plus 8 is 12. Okay. 7 plus 1 plus 9, that would be 17. 6 plus 1 plus 1 would be 8. 3 plus 2 would be 5. And then we just have our 1. So when we put our comma in the correct place, we have 158,725. Now, I am going to grab a calculator and check it. This is always a good idea, especially when you see these on weekly reviews, all right, or an isolated practice sheet. So 6,349 times 25 equals 158,725. Perfect. Now, if this did not give me the right answer, there's a quick way to figure out where your work is or where your mistake is in your work without having to erase everything and start over. So if you take your top factor, 6,349, and multiply it by 5, you can check to see if you have the right partial product on the first row. If that's correct, then what you want to do is take your 6,349 and multiply it times not 2, but 20, and see if you have the correct partial product on that row. If both of your partial products are correct, then your mistake is in addition. So then you need to put your calculator aside and you do need to rework your addition. Okay? So that is how you find your careless mistake when you have all this computation work going on. All right? You can check each of those rows at a time, each of those partial products. All right? I'm wondering, do you guys want to do one more? Let's do one more of these. So let's just write down, I don't know, let's just do 4,321 times 54. Okay, so let's start there. So I'm going to grab my different colors. I'm going to try to leave both of these up so you can refer back to the one we just worked on. So we're going to ignore the 5, and we're going to treat this as 4,321 times 4. So 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. Don't forget, we had to regroup. 4 times 4 is 16 plus 1, 17. All right, I'm going to cross out anything that I regroup so I don't accidentally use it again. And I am ready to multiply by the 50. So I'm going to put a 0 down. This has to always be in the ones place on your second row of partial products, or your answer will not be right, because we're not multiplying by 5. We're really multiplying by 50. That value is 50. All right. 5 times 1 is 5. 5 times 2 is 10. We're going to regroup that 1. 5 times 3 is 15 plus 1, 16. 5 times 4 is 20 plus 1, 21. Okay, so we have 2 rows of partial products. So I'm going to slide over and think about what each one of these means. You do not have to do this work out to the side. This is just me thinking to make sure you understand that 17,284 is the partial product. It is the result of multiplying the top factor times 4. All right. The 216,050 is the partial product. That is the result of multiplying the top factor times 50, which explains that 0 there. We add the partial products. 4 plus 0 is 4. 8 plus 5 is 13. 2 plus 1 is 3. 7 plus 6 is 13. 1, 1, and 1 is 3, and we get the 2. So when we put our comma in the right place, we get 233,334. And of course, I'm going to want to check it. That much work, that much effort, I'm going to make sure it's correct. So 4,321 times 54 equals 233,334. That is exactly what I have for the product. Now, if that is not correct, don't forget, we're going to check it piece by piece, meaning we're going to take that first product, 4,321 times 4 is how we got that, and we're going to make sure that it is correct. If it is, we're going to look and see if when we multiply 4,321 times 50, do we get 216,050? We do. So again, if those are correct, then our mistake has to be in the addition, which some of you guys, it's kind of strange, but when you make a mistake, it's the silly things like addition and subtraction. All right, so that is how we multiply by a 2-digit number. Your work should look like mine. You don't need this pencil part that I'm covering up right here. If you want to write it for the first couple times just to make sure you understand where these partial products are coming from, you can do that. But if all I see is that for your computation work, that's fine. All right, let's review real quick division. All right, I am going to start with 4,869 divided by 7. We are going to slide over, and I'm going to show you, first of all, the standard algorithm, breaking it up into those place value slots. So the 4,000s, the 800s, the 610s, and the 9 ones. We'll come down, and you're making your workspace. And then you're separating a little workspace for each place value. Okay, so when we divide, I cannot divide 4 by 7. Can't make any groups with anything less than 7,000 right here. So that's going to be a 0. So we have not used any groups of 7. So this 4,000 is going to be renamed or regrouped as 40 hundreds. And we're going to put it with the 800s that we already have, which is why we have 48 right here. Okay. Now, how many groups of 7 can you make with 48? That would be 6. And that's because 6 times 7 is 42. All right. We've only used 42 of the 4800s. We still have 600s that we can't make equal groups of hundreds because we don't have enough 7s. So we're going to rename this or regroup this 600 as 60 tens. And we already have 6 tens. So now we have 66 tens that we're going to make equal groups of 7 with. All right. I actually could make 9 groups of 7 with 66. And that's because 9 times 7 is 63. All right, I still have 3 groups of 10s that I can't make equal groups of 7 with. So these 3 10s are going to get regrouped as 30 ones, and I'm going to put it with the 9 ones, and now I have 39 ones. And I can make 5 equal groups of 7 with 39, because 5 equal groups of 7 would be 35. Now, I have 4 that I can't make an equal group of 7 with because I don't have enough. So that is what we call the remainder. So my answer is 695 remainder 4. I just worked this with the standard algorithm. This is how your mom, dad, your grandparents learned how to divide, except for we are using a different organization strategy by breaking it into place value slots. What I'm seeing the benefit of this right now is that we're not making as many careless mistakes. If you understand each of those steps, then I hope you understand this. We used to teach it as learn the steps. Does McDonald's sell burgers? That means you divide, then you multiply, then you subtract, and then you bring down. But all we were really teaching you at that point was the steps, and we weren't teaching you the understanding of what you're doing. So if you forgot a step and you didn't understand what you were doing, you would get the problem wrong. I think this helps you understand what the conceptual part is a lot better. Now, some of you are already working with these steps, but I want you to really understand what you're doing. So let's talk about it. All right, we cannot make equal groups of 4 with 7. And I don't usually do the 0 and then multiply. What I usually do is I say, okay, I know I can't make equal groups of 7 with 4, but I can make equal groups of 7 with 48. So I put what I call a little caret here, and that lets me know that I'm starting right here by making 6 groups of 7 with 48. 6 groups of 7 is 42. And what I have left 600s because I've 48 hundreds. I made 6 groups of 7 and I used 42 of my hundreds. So these 600s right here that I cannot make an equal group with, I'm renaming it 60 tens and putting it with these 6 tens that you bring down. Okay. And I think by learning does McDonald's sell burgers, we're not understanding what's going on there. So we're really now dividing into the 66 tens. Doesn't it make it a lot easier to see it over here when we talk about it? All right. So how many groups of 66 tens can you make with 7? You could make 9 groups because 9 times 7 is 63. When we subtract, we have 3 groups of 10 that we cannot make groups of 7 with. So we're going to rename this as 30 ones, and we have 9 ones that we can put it with. So now we have 39 ones. So how many groups of 7 can you make with 39? That is going to be 5, and that's because 5 groups of 7 is 35. And then you have 4 groups of 1, or 4 ones that you can't make another group of 7 with. So this is called the remainder. Now, notice I did not go through divide, multiply, subtract, bring down. That helps you with the steps, but it doesn't do anything with helping you understand really what's happening, okay? So I'm trying to avoid that because I'm wanting you to really understand what you're doing, all right? When we learn all these little sayings and all these little tricks, yeah, it's great, but then you get so many in your head, you don't know when to use them. If you understand what you're doing, like I see happening here, then I think you're more likely to, 6th grade, 7th, 8th, so on, you're going to be so much better off when we do slide over and use this setup for this traditional or standard algorithm. Now to check this, you're not going to pop it into a calculator because look what happens. When you put 695, didn't even do that right. When you do 4,869 and divide it by 7, you're going to get this funky long number, 695 and 57 hundredths if we want to round it to the nearest hundredth. I shouldn't see an answer like that because we're calling the remainder that you just have, that you just have 4 left over. All right, so let me show you how you check this. You check multiplication with check division with multiplication. So we're going to take the whole number part of the quotient and we're going to multiply it times the divisor. 7 times 5 is 35. 7 times 9 is 63 plus 3, 66. 7 times 6 is 42 plus 6 is 48. And then we add the remainder. So I get 4,869. If what I get, is the dividend, which it is, then I know the problem's correct. Okay, so we multiply, and you can do that with a calculator. You don't have to do this. Just real quick, 695, the whole number part of the remainder, of the quotient without the remainder, times the divisor, get your product, add the remainder if there is one, and that should equal the dividend. And if you check it and that's correct, you know it's right. No reason not to check your work with a calculator. It's the not doing your work with a calculator. It is checking it. So I'm going to give you a couple of multiplication problems with the 2-digit multiplier, couple review with the 1-digit divisor. We're not ready to go to 2 digits yet. And what I want you to do is make sure that whatever setup you use for the standard algorithm, I want you to make sure you're checking that with a calculator. Okay, I just showed you how to do it. With that being said, have a great day, and if you need me, reach out.